In lesson 4, we're going to be talking about arithmetic series or arithmetic series. Up to this point, we've been talking about sequences. So if I have a sequence that goes 3, 5, 7, 9, 11, then I'm going up by 2 each time. So 3 plus 2 is 5, plus 2 is 7, plus 2 is 9, plus 2 is 11, and so on. In a series, what we're doing is we're adding all of our terms in our sequence. So we're working with sequences still, but now we're going to be adding our terms together, so that makes them series. So if our terms were 3, 5, 7, 9, 11, then we're going 3 plus 5 plus 7 plus 9 plus 11, and then we're going to be taking the we're taking the sum of those and we're adding them for our grand total here of 3 plus 5 is 8 plus 8 of 35. So when I talk about this series, the symbol Sn is going to be used to represent the number of terms that we have in that series. And in this case, we have 1, 2, 3, 4, 5, which means that S5 would be 35. All right, so S5 would be 35 because there's 1, 2, 3, 4, 5. Now, if I was using S4, just the first 4 terms, then we would have a sum of 24, right? And so, depending on how many terms you have in your sequence is going to dictate what the actual term, what the sum, what your series is going to be. I'm just going to kind of skip over this investigation, and we're going to head into the, well, we're going to look at the formula that we're going to use for our series, and then we're going to take a look at the examples for this lesson. All right, so in an arithmetic series of n number of terms, so just any number of terms, the first term is a, so that stays the same, right? The second term is going to be a plus d, which is still the same, and the last term is going to be represented by our general formula. So nothing has changed up to this point. The sum of n terms then can be written like this. Now, this is very convoluted, and when you look at this, it's understandable if you're going to be a little freaked out. But don't worry, because everything that's written here can be summarized by our formulas. Sn is equal to n, being n terms, and 2a plus n minus 1 d divided by 2. So, yeah, this formula connects all of our variables a, d, n, and Sn. And then, secondly, we have our formula for the sum of the n terms in an arithmetic series, which is Sn n times a plus tn divided by 2. And don't worry, we are going to be using these formulas more. So if anything I just said now doesn't make any sense, do not fear. All right, so we're going to be using both of these formulas in this lesson. So let's look at example number 1. So in example number 1, we want to determine the sum of the first 14 terms of the series 9 plus 15 plus 21. Now we're only given 3 terms, right? Which means that we got to determine what our difference is, and that's stuff we can do though. So we know that in any question that we're doing in pre-calc 11, we need to start by making a list of the variables. What are the known pieces of information that we have? Well, first of all, we know what our first term is. Our first term is 9. We know what our difference is, right? We know that the difference from 15 to 9 is 6. From 21 to 15 is 6. So we have a common difference of 6. And we know what our value of n is because we want to know what the first 14 terms are going to be. Now what we want to do is input this into a formula. So we want to determine the number of terms. So the number of n terms, right? Which means that we want to use that first formula we looked at. And the first formula we looked at was Sn is equal to n times 2a plus n minus 1 d. And we're going to be dividing that all by 2. All right? So that's the first formula that we were taking a look at. Yeah, now we have our known piece of information, we have our formula. Now all we gotta do is plug everything in. So Sn, n being 14, n is 14 times 2 times a, which was 9, plus n, which is 14 minus 1, times d, which is 6. And we're dividing all of that by 2. Now, this is where we got to be careful, is how we actually input this into our calculators. If I remember, you need to keep track of your orders of operations, and so when doing that, I find it helpful to break it down first. So rather than just putting everything in your calculator then pressing enter, I do it in stages at the beginning. But once you get more comfortable with working with these formulas, you can put it all in at once, and yeah, you'll probably have no problem there. So we have 14 multiplied by 18 plus 14 minus 1, 13 times 6, 78 plus 78, and dividing that by 2. Now this gives us something we can work with. We have 18 plus 78 times 14 divided by 2. We have our answer of 672. That is the sum of the first 14 terms in the series 9 plus 14, or sorry, 9 plus 15 plus 21, so on and so forth. All 14 terms. Alright, now let's look at this next example. This is class example number 2. Determine the sum of 22 terms in a sequence with t1 is equal to negative 18 and t22 is equal to 45. So it's just like we did here. The only thing is we don't, well actually no, we have all the information we need. Right, but let's begin by making our list, right? A, or t1 is equal to negative 18. Actually, there is one thing we don't have. We don't have our difference. We have our 22nd term, however, so we can determine what our difference is going to be. We also know the number of terms we're looking for, n, and that is 22. Now this is a good question because we don't have the difference. Usually that's something that is given to us, right? So yeah, this is a pretty sweet question. So, but let's take a look at how we would actually go about finding our difference. So we are given term 22, right? And that is 45. Now remember, we can use shorthand of our general equation for term 22, which is a plus 21d, and that is equal to 45. We can also use the shorthand of our equation of term 1, and that is equal to a is equal to negative 18. We don't have 21d. Now, in order to solve for our difference here, we're just going to end up combining these equations. Alright, so when we combine these equations, we're going to be left with, well, this becomes a subtraction equation, right? So we're going to be left with 21d subtract 18 is equal to 45. Now, as we solve, now we can solve for d because we have our like variables that we need to combine. So if I add 18 to both sides, I'm going to leave with the 21d is equal to 63. And if I divide both sides by 21, I get my difference of 3. So d is equal to 3. Now I have enough information that I can plug into my equation. So Sn is equal to n, that's 2a plus n minus 1, multiplied by my difference and divide that by 2. And we're looking for S22 here. So S22 is equal to 22 times 2 times negative 18 plus 22 2 minus 1 times negative 18. All of that divided by 2. And again, stages will probably be very helpful in solving this. So when we plug this into our calculator, we get an answer of 297. And again, go back, do this in steps, but you should be getting 297 as your answer. Next, find the sum of the terms in the sequence 17, 12, 7, negative 38. This time we don't know how many there actually are. So let's write down what we do know. We have our first term, which was 17. Now we have enough information to determine where our difference is going to be, so that's kind of nice. Our difference is going to be changing by 5 each time, going down, so negative 5. And we have a last term, possibly, which is negative 38. We don't have n, though, right? We have what the last term is, but we don't have how many terms that is. So in order to determine that, we are going to need our general formula first and foremost. And so our general formula, remember, is Tn is equal to a plus n minus 1 times d. Tn equal to negative 38 is equal to 17 plus n minus 1 times my difference, which was negative 5. Distribute that difference into your equation. You're going to be left with negative 5n plus 5. Combine our like terms, and we're going to be left with negative 38 is equal to 22 minus 5n, and subtract 22 from both sides gives negative 60 is equal to negative 5n. Now divide by negative 5 on both sides of our equation, and we get a value of n equal to 12. Alright, so now we have what n is. No longer a question. Now it is 12. Let's plug that into our equation to find out what the sum is going to be. And yeah, let's throw it in there. Sn is equal to n times 2a plus n minus 1 times the difference, which was d, divided by 2. Sn, n being 12, we know that our value of n is 12. So 12 times 2, a is 17, plus 12 minus 1 times the difference, which was negative 5. All of that divided by 2. And let's plug this all into the calculator. I get an answer of negative 126. Now, notice I'm only using the first formula, but for these two questions specifically, we can also use this formula. Sn equals n times a plus Tn divided by 2. That will also work. And sometimes you might find that it's simpler to use this one because you don't actually need one of your variables. You don't need the difference. Okay, last question here. Peter starts work at a salary of $16,000 per year per annum. He receives annual increases of $850, and he works for the firm for 12 years. Calculate his salary in the 12th year. So we know that in the first year he was making $16,000 per year, and every year he gets paid $850 more, and he works there for 12 years. So those are our variables that we know of. What we want to do is calculate what his salary is going to be in that 12 years. So what we're looking for here is T12. Now we can solve that one pretty easy, right? Because we know that T12 will have a general formula of A plus 11D. Now T12, if A is 16,000, we can add 11 times the difference, which is 850. T12 ends up being 16,000 plus 850 times 11, $25,350. So that's what his salary is going to be in 12 years. Now, how much, this is where sums come in, is how much has he earned in the 12 years? So to determine what he earns in 12 years, all we got to do, well, I'm going to use that second formula for you this time. You can plug it into the first one we've been using, but if we use that that second formula, so the formula for the sum of the number of terms for the sequence, Sn is equal to n times A plus Tn divided by 2. I put one too many brackets last time. So we know that n is equal to 12 years. We know that A was 16,000, term 1. And we also know that Tn, or term 12, is 25,350 divided by 2. And so it's kind of nice because this formula is a lot shorter. There's a lot less variables to keep track of. So 16,000. Don't forget your brackets for these questions. So in total, if he saved everything, didn't spend anything, didn't spend a dime, Peter would have made $248,100. And I don't know why that extra 8 is there. That's a mistake. So 248,100. That's the answer. And I think there's one more example I wanted to do, but I don't have it in front of me. So it is fairly straightforward, though. I did write it down. Yeah. So if we're given this series, it's an arithmetic series. So we have enough information, and we want to determine what the first 4 terms of the sequence would have been. So if you're given something like this, and you want to find out what the first 4 terms of a sequence are, then all you need to do is take this formula, or whatever formula you're given. It might change from time to time. And then if I'm looking for the first term, so term 1, that means that n is equal to 1. So all I do is plug 1 into that series. 11 minus 1, so 1/2 times 10. That means that my first term was 5. Right, so we do the same thing for term 1, term 2, term 3, term 4. And this is example 5 in your textbook. So give that one a shot. If you can't handle it, then make sure you, just ask me.